Today we're going to be learning about direct, inverse, and joint variations. This is section 9.1 in the Algebra 2 book. When you are working with direct, inverse, and joint variations, there are three formulas, one for each type, that you need to learn. The direct variation formula is y equals kx. K is called the constant of variation, and k is something that first we have to find, and then we're going to use it after we have it. It's a number that's constant for the problem that you're working with. Now k, the constant of variation, appears in all three of our formulas, so don't forget whenever you're writing your formula, you always have to put the k in the formula. It's always there. In a direct variation, what that means is one variable is increasing as the other one increases. If you work at a job, the more hours that you work, the more money you're going to earn. So that's a direct variation because the amount of money that you earn is directly related to how many hours that you work. In inverse variation, the formula is y equals k divided by x. K is still called the constant of variation. It's still a constant number that we're going to find and then use for that problem. And in inverse variation, one variable is increasing while the other one is decreasing. If we were going to have a bunch of people chip in to buy pizzas, the more people that you have to chip in, the less the cost for each person. So that's an inverse variation. As the number of people increases, the less the price for each person. In a joint variation, the formula is y equals kxz. Again, k is still called your constant of variation. It's still something that you're going to find and then use. In a joint variation, as one variable increases, the other ones increase. An example of this would be like volume. Volume is based not just on one dimension, but on three dimensions: length, width, and height. So this is called a joint variation because it's like lots of different dimensions that would affect your volume. If the length increases, so will the volume, or the height, or the width increases, that would increase your volume. So a joint variation is based on many different variables, not just like one variable. Okay, we're going to write the formula for each one of these, just practicing how to write formulas. On number 1, it says y varies directly with x, so our formula is y equals kx. That's the direct variation formula. On number 2, it says y varies inversely with x, so think about what that inverse variation formula was, and it was y equals k over x. On the next one, it says y varies directly with the square of x. So you want to use the direct variation formula, but you want to use the square of x instead of just regular x. Here's how that looks. Y equals kx squared. Number 4, z varies jointly with x and y. Z varies jointly with x and y. Think about the joint variation formula. You want to use the variable z first at the beginning, and then x and y later on. So z equals kxy. Number 5, z varies jointly with x and y and inversely with w. Think about the joint variation, and then how would you put an inverse variation with that? So joint variation, z varies jointly with x and y, that would be z equals kxy, and then inversely with w means we're going to have an over w part to that. That's for the inverse variation that always has the divided by in it. And then the last one, number 6, y varies inversely with the cube of x. We want to think about what the inverse variation formula looks like, but we don't want to use regular x, we want to use x cubed. So y equals k over x cubed. Okay, now that we've practiced writing formulas, we're going to do some actual examples. Here's our first example. A varies directly with b. Okay, let's stop right there. A varies directly with b. So our formula is a equals kb. That's the direct variation formula using an a and a b. Now it says a is 15 when b is 3. So stop right there and let's put that in. A is 15 when b is 3. Now we want to stop and solve for k because we can do that. When we do, we get k is 5. Okay, let's keep reading. Find a when b is 12. So we're going to go back to our original formula, a equals kb, and we're looking for a. We know that k is 5 because we just found that a few minutes ago. And we know that b is 12 because they just told me that. So 5 times 12 would be 60, and that's the value of a, which is my final answer. Okay, look at the next one. C varies inversely with d. Stop right there, let's write the formula. C varies inversely with d. Think about the inverse variation formula. C was the first variable, so it goes first, and then D was the second variable, it's going to go later. So C equals K over D. Okay, now it says that C is 5 when D is 10. So stop and put those in. C is 5 when D is 10. Alright, we can solve for K right now, so let's go ahead and stop right here and solve for K. You're going to multiply the 10 over to the 5, making 50. So K is 50. Now we're ready to solve the problem. It says find C when D is 2. So we're going to go back to our original formula, C equals K over D. We're trying to find C. We know D is 2, and we know K was 50. So 50 divided by 2 would be 25, and that's my final answer. On the last one, if F varies jointly with G and H, stop right there. F is varying jointly with G and H. So think about the joint variation formula, and you want to use F and G and H as your variables. F and G and H. So F equals KGH. Now it says F is 80 when G is 5 and H is 8. So stop right there and put those in. F is 80, G is 5, H is 8. And we can solve for K, so we're going to stop right here and solve for K. 5 times 8 would be 40, and 2 times 40 would be 80, so K is 2. Now that we know K, we're going to go on and finish the problem. It says find F when G is 16 and H is 2. So go back to your original formula, F equals KGH. We're trying to find F. We know that K is 2, we just found that. G is 16 because they told us, and H is 2 because they told us. So 2 times 16 times 2 would be 64, and that's our final answer. Okay, now let's look at this in a word problem. The length of a rectangle of a certain area varies inversely with the width. Alright, stop right there and think about the inverse variation formula. We have the length varying inversely with the width. Here's what our formula is going to look like. Length equals K over width. It says the length of the rectangle is 9 when the width is 6. So let's stop and put those values in. 9 is the length, 6 is the width. And we can go ahead and solve for K, so let's do that before we go on. Multiply the 6 times 9, and you get 54, and that's K. Now let's finish the problem. Find the length when the width is 8. So let's go back to our original formula. Length equals K over width. We're trying to find the length. We know K is 54, and we know the width is 8. So 54 divided by 8 is 6.75. So the length would be 6.75, and that's centimeters that we were working with here. So 6.75 centimeters. Okay, one more. This is a combined variation. This is kind of putting it all together. The original problem says Z varies directly with the square of Y and inversely with X. Stop right there and let's write the formula. Z varies directly with the square of Y and inversely with X. For the first part, Z varies directly with the square of Y. Here's how that looks. Z equals KY squared. Now we want to do inversely with X, so you're going to put over X. So altogether the formula is Z equals KY squared over X. Now they're going to give us some numbers. Z equals 16 when X is 2 and Y is 4. So let's plug in those numbers. Z is 16, X is 2, Y is 4, and don't forget that Y is being squared, so it's 4 squared. Okay, we can solve for K, so we're going to stop and do that. Multiply the 2 over to the 16, that's 32, and divide that by 4 squared. 32 divided by 4 squared, or 16, would be 2, so K is 2. Now we're going to answer the problem now that we've solved for K. It says find Z when X is 4 and Y is 1. So go back to the original formula, Z equals KY squared over X. We're looking for Z. We know K is 2 because we just found that. We know that X was 4, that goes on the bottom of the fraction. And we know that Y is 1, and don't forget that we're squaring that. So 2 times 1 squared divided by 4. 2 times 1 squared is 2, divided by 4 is a half. So Z equals a half, or you can say 0.5 if you like decimals better.